Well, I have something completely new to say. So I would like to consider, how about a parabola? Clearly, this is a parabola opening to the right. Vertex is 0, 1. But if it's opening to the right, that means y is not a function in x. I certainly don't satisfy the vertical line test. However, to differentiate, what you and I would probably do is dive in and isolate y, solve for y in terms of x. And to differentiate, that's what I have. So technically speaking, what I've done is the following. To find y prime or dy dx, starting off with the equation x and y, what you and I have done so far is we've solved for y in terms of x. Then we get that y is equal to some junk in x. And then we differentiate what I sometimes say explicitly, getting that y prime is equal to some junk in x alone. Now, as an alternative, I sometimes don't isolate y first, and I differentiate implicitly. If I do, then I get an equation in x, possibly y, and y prime, or dy dx. And then I will solve for y prime. I'm an abstract algebraist, so I typically say this diagram commutes. As long as you can go in both directions, you'll get the same result. That being the case, let me go back to my example and see if I can't come up with y prime in a slightly different fashion. So let me start off with the original relationship. Now, I know y is not a function of x, but let's treat y as a function in x and differentiate implicitly, meaning I'm implying that y is a function of x briefly, with respect to x. So here I go. Now remember, y is understood to be some function of x. And so when I dive in and differentiate with respect to x, on the left-hand side, life's a piece of cake. I just get 1. On the right-hand side, life's not a piece of cake. I've got composition all over the place. So differentiating the outer squaring most function first. I'll bring the 2 down and reduce the exponent by 1. But the chain rule says I have to multiply by the derivative, please excuse me, with respect to x of whatever the HECK I was raised in the second power. But the derivative of y minus 1 with respect to x is the derivative with respect to x of just simply that y. And now to solve for dy dx, or y prime, whatever you want to call it, I see that dy dx is a 1 over 2 times y minus 1. Oh shoot, did that not work? That looks so different than this. Oh, but wait. According to the original relationship, another name for y minus 1, if you take the square root of both sides, is plus or minus root x. So technically speaking, I can rewrite this as 1 over 2 times the square root of x plus or minus, and of course, as desired, I get exactly the same result I had before.